Once again, this is going to be a recap and extend into chapter 4.2. Anyone want to, I guess, suggest, is there any difference between the sine, cosine, and tangent of this triangle with its mirror image? Clearly, it's a mirror image. We see that. But in terms of the ratios, is there a difference in measurement?
No.
Sorry, say that again?
No.
No. Sorry. My baby is watching a cartoon. Ugh, aside. The answer is no, of course not. The reason behind that is, remember, if we're dealing with theta, right? This is the opposite, that is the adjacent, and of course that's the hypotenuse. In the same way, although the triangle is flipped, my theta still calls the side with length of 4 opposite, and the side length of 3 adjacent, and the 5 is the hypotenuse. So for the red triangle, opposite over hypotenuse, and for the blue triangle, opposite over hypotenuse, it's exactly the same. Cosine, 3 over 5, cosine, 3 over 5, tangent, opposite over hypotenuse, tangent, opposite over hypotenuse. Any questions so far? No? Okay. Well, this is where it gets a little bit interesting. I am drawing the exact same two triangles on the left side and right side, and, of course, the angles that I draw are going to be the same for this triangle. I know I said in the previous class that the angle has to start from the x-axis, so the initial arm, and I'm counting the angle this way, but just bear with me for a moment. If I draw those two triangles, what is the length of the base for the blue one? It's a 3. The height of the blue one, it's a 4. So this is my opposite. This is my adjacent, right? So sine would be 4 over 5, cosine 3 over 5, and tangent 4 over 3. So on the flip side, I would say the exact same thing. What is the length of this base? Technically, it's a 3. Technically. What is the height of this triangle? Well, it's a 4. The only difference when we talk about just triangles versus when we are talking about in a Cartesian coordinate, the red triangle on the left side is in a quadrant where all the x values are negative. Remember, the 3 and the 4 in the previous quadrant came from here. So if I'm talking about the second quadrant, so in other words, from 90 degrees, so this is 0 degrees, 90 degrees to 180 degrees. If we're talking about a point in the second quadrant, I know that the length is 3. We don't talk about a negative length. But if we're talking about coordinates here, and we're talking about a ratio between the coordinates on a Cartesian, the sine, of course, is opposite over hypotenuse, but the cosine is adjacent of -3 over hypotenuse. And the tangent is opposite, a positive 4, over adjacent, -3. So angles between 0 degrees to 90 degrees, which is in the first quadrant, right? In the first quadrant, all the ratios are going to be a positive. But as soon as we pass 90 degrees, from 90 degrees to 180, which is right here, right? 90 degrees to 180, right here. I'll draw it as a thicker arrow. Okay. The second quadrant, every single ratio that uses my x value is going to be negative. In other words, sine is going to always be positive from 90 to 180 degrees. But cosine and tangent are inevitably going to be a negative. Which of course means, since we're talking about a circle here, we should also explore what happens in the third quadrant, so quadrant number 3, and the fourth quadrant, quadrant number 4. And that is how we are going to start our lesson and fill out that sheet. Any questions before we begin? Or do you want to hold off until we fill out the sheet? Any burning questions? Okay, let's explore. We are going to take a look at primary trig ratios in a Cartesian coordinate, specifically in talking about or dealing with circles. Here we go. All right. If you have your sheet with you, I am going to continue. I'm going to use the point 3 and 4. Just like we did before, if this is my terminal arm in the first quadrant, so Q Roman numeral 1, my y value is going to be a 4, and my x value is going to be a 3. And if you remember from above, instead of using opposite and adjacent, we are now going to be dealing with x, y, and r, right? In the notes that I had above. So for sine, let me see if I can match this again. For sine, we are now using y over r, which means 4 over 5. Cosine is x over r, which is 3 over 5. And tangent is y over x, which is 4 over 3. So just from having a single point, we can not only calculate the radius, but we know what the ratios are for that angle. So do you see sort of, while you're copying this, do you sort of see the value in this? Typically for a triangle, you needed an angle and you needed like at least you needed to someone to tell you that it was for sure a 90 degrees and you had to have one of these points, right? There was a lot of different things that had to be fulfilled, a lot of conditions. But for a circle, because we're in a Cartesian system with x's and y's, all you need is a single point and everything else sort of falls into place. Let's take a look at what I mean. I'm going to do the exact same point, but on the other side. I'm going to mirror image it. So negative 3 and 4 creates the exact same imaginary triangle on this circle, but in quadrant 2. Please notice that I'm always creating a triangle with the x-axis. I'm not doing this. I'm not creating this triangle, right? Anyways, there's a reason that I'm doing that. I just want you to get used to it and follow a system. Okay, so that's negative 3 and 4. Sine is y over r. Someone who wants to sort of confirm their thoughts, what do you think the sine ratio is in the second quadrant?
4 over 5.
4 over 5, absolutely, just like before. And the cosine would be adjacent over hypotenuse, in other words, x over r. Someone else?
Negative 3 over 5.
Negative 3 over 5. And following opposite over hypotenuse, opposite over adjacent, which is y over x, is 4 over negative 3. Now, while we're going along, I'm going to start highlighting all the terms that are positive. So for the first quadrant, every single ratio is positive. So I'm just going to highlight all of them. And there's a reason behind it. You can do that too if you like. For the second quadrant, only the sign is positive. Okay, next, let's move on to the third quadrant. So quadrant, maybe we should put a little note on that too. This is quadrant 1. Quadrant 2, we say Q2 in Roman numerals. This is quadrant 3, so that's I'll just do it here, Q3 in Roman numerals. And I have the exact same point, except because the x and y values are both negative, it will be -3, -4. What do you think? Somebody else. What is y over r? Come on. I don't need you to figure things out. I just need you to participate. Try to match values. What's the y value?
-4.
Ooh, Josh, you're the only one that's like willing to say something. Maybe everyone else is a little scared. X is a -3, and the radius is still a 5. So, y over r, -4 over 5. Cosine, x over r, -3 over 5. And tangent is y over x, -3 over, oh, sorry, -4 over -3. A negative divided by negative is basically a positive. So I'm just going to write 4 over 3. I'm also going to take a color and highlight the only ratio that happens to be positive. To complete this note, this would be a 3, -4. I'm going to finish this off. The base of this triangle, again, I'm making the triangle along the x-axis. I am not trying to create any triangles with the y-axis, okay? The height, or the y value, is going to be -4. My x is a 3, my y is a -4, my radius is a 5. Sine would be -4 over 5, cosine 3 over 5, and tangent -4 over 3. The only ratio that is positive in this one is cosine. So why am I getting you to go through all of these quadrants? There's so many different things that I can pull out, so many different relationships I can talk about here. But here is, I think for now, the most important ones are these two. You will notice that all of these trigonometric primary trig ratios are written in terms of x, y, and r, as I've been constantly saying. What do you also notice about the actual values? Forget the negatives. What do you notice about the answer or the fractions of every single ratio here? Are they similar? Are they different? Right. Yes, correct, Kennedy. Radius, we will never call that negative for two different reasons. Number one, we're dealing with, if you do Pythagorean theorem, if I have -3 squared plus -4 squared, it's still going to be a positive 25. There's no reason for the radius to be written as a negative. Okay. Um, Another way is the radius simply means a length, and so we typically try to keep the value a positive. So again, take a look at all the sine values, everyone. It's 4 over 5, 4 over 5, -4 over 5, and -4 over 5. Next, I'm going to erase these circles, by the way. You don't have to circle it. Cosine is 3 over 5, 3 over 5 but negative, 3 over 5 but negative, and 3 over 5 positive. Tangent, 4 over 3, 4 over 3, 4 over 3, and, oops, 4 over 3, and 4 over 3, but there are some negatives in there. What I want you to notice is that all of these values are exactly the same as my original triangle in quadrant 1. We just got to figure out what the negatives are. You get what I'm saying? Right? This is an observation that we make, and this is where Castro comes in. And this is super important, so I want everyone to chime in. Does everyone recognize that all the fractions, all the ratios are exactly the same? So all we have to do is figure out where the negatives come in. Did you understand that part?
Yes.
Yes? Everyone else? Thumbs up, thumbs up, thumbs up. What I'm trying to tell you is this. There's a shortcut. We don't have to know the entire circle. All we have to know is figure out the positive quarter of it And we can basically copy and paste that to all parts of a circle because it's symmetrical, as long as we know where the negatives go. So if you know how to do SOHCAHTOA, here's how you can figure out the entire circle using just SOHCAHTOA. Starting from the fourth quadrant, I'm gonna do this, okay? Starting from the fourth quadrant, the only ratio that is positive is cosine. Okay? In the first quadrant, the only ratios that are positive are, well, all of them, A for all. In the second quadrant, all the ratios are negative except, oops, I'm trying to erase these circles. Okay. All the ratios are negative except sine. And in the third quadrant, all these ratios are negative except tangent. If you read it from fourth quadrant to third quadrant, we spell the word cast. So that's why we call it the cast rule. In other words, if you're able to figure out what the value is in the first quadrant, all you have to do then is to figure out, is the angle pushing me into the fourth quadrant? Does the angle push me into the third quadrant? Does the angle push me into the second quadrant? Or does the angle push me into the first quadrant? And then you just plug in your negatives accordingly. Let's say, for example, let's say your angle, your cos or your sine theta, I know it's supposed to be 45, 4 over 5. But the angle is like 100 and something, like 120 something. Then I know it's in quadrant 2, which means the answer 4 over 5 and the quadrant 2 4 over 5, they're exactly the same. Okay, that's all I'm trying. So we're going to explore in chapter 4.2 how to look at a degree, look at an angle, match it with quadrants 1, 2, 3, or 4, figure out whether it's going to be positive or negative or not, and then answer it. Cast rule is supposed to make your life efficient. So right now it might be a little confusing, but bear with me. Okay? So this is the intro to cast rule, and 4.2 we're going to talk about today. We'll talk about tomorrow in class after the test, and you'll see more of it pop up here and there. Okay? All right. Let's hold off for a sec. I'm going to clear this screen. If you're still busy copying, know that it is being recorded so you can wait for the video soon. For those of you who are ready, I'm going to move on to chapter 4.2. I'm going to talk about something called being coterminal, and then we're going to start exploring how to use cast rule effectively. Okay? Any questions? Okay, let's do this. How much time do I have? Still got plenty of time. We can do this, everyone. All right, breathe, breathe. A couple of terms. We've learned about initial arm. We learned about terminal arm. Okay, initial arm being, if this is a Cartesian coordinate, the initial arm is right here. We always start at the x-axis. And the terminal arm is wherever we stop. That's going to be my angle. Also notice that up until now, I always rotated in a counterclockwise direction. Long story short, that's going to be moving in the positive direction. If I have 90 degrees, I'm moving this way 90 degrees. Once again, if I say theta is 45 degrees, from the initial arm, I'm moving this way 45 degrees. If I say theta is 180 degrees, I'm moving this way 180 degrees. Okay? It's always going in the counterclockwise direction. So if that's the case, what if I said negative 45 degrees? Logically, what direction do you think I'm turning?
Counterclockwise.
No, other way, clockwise. We're already moving counterclockwise, so it's going this way. That would be
Clockwise.
negative 45. And so this, because we have potential to have negative angles, we need to talk about the possibility of them landing in the same location. Take a look. I am going to introduce a new word called coterminal angles. In other words, angles where the terminal arm lands at the same location. Here's an example. If you're with me, please follow along. Let's pretend, just hypothetically, this angle right here is 25 degrees, right? So this is my terminal arm. Terminal arm. But you can also say that if that is where I'm stopping, I don't have to go right directly there. I can also say that hmm, I might have actually rotated a full 360 degrees before landing there. In other words, I could also argue that a full 360 degrees plus the extra 25 degrees will land me in the exact same location. And I hope you understand that portion, right? I'm fixed at 0, 0, so it only makes sense. And so that means the angle of 25 degrees will give me the same calculations, the same ratio, the same values as 385 degrees. And so instead of, so because of that, we give them a special term. They say 25 degrees and 385 degrees are coterminal. Things like, so just an example, 0 degrees, 360 degrees, 720 degrees, and the infamous 1080 snowboarding, 1080 degrees, they are all coterminal. And just for fun, if I have 2 degrees, 362 degrees, 722 degrees, and 1082 degrees, they are all going to be coterminal because they have a difference of 360. What's interesting, I could go backwards. If I do the clockwise direction and say negative 360, negative 720, negative 1080, they are still coterminal. But this one's the hard one. As the numbers increase, or the numbers are different from values of 0, negative 358, negative 718, and negative 1078 degrees, they are coterminal. So a simple way that we like to write it as a general formula is, how do you show something is coterminal? Well, take the angle and add multiples of 360 multiplied by some number where n belongs to integers. For example, just like I did before, if theta is equal to, let's say, 30 degrees, if n is equal to 1, that means the angle I'm talking about would be 30 plus 360 times 1. That's 390. If n equals 2, that means 30 plus 360 times 2. So that would be 30 plus 720, that's 750. These are all coterminal. If I'm going too fast, just know that what I'm doing here is basically 30 plus 360 multiplied by 1. And here is 30 plus 360 multiplied by 2. So on and so forth. And of course, n could be like negative 3 because it's still an integer. It still works. That will be 30 plus 360 times negative 3, which is 360 minus 1080. 330, 1080, 1050, negative 1050. They are all coterminal. At this time, I would normally stop and ask people to raise their hands of are there any questions with the concept, or would you like to try some practice questions? Judging from the silence, I'm going to say you're going to try to practice questions. I'm going to clear this. Thanks, Aiden. Oh, Aiden, you're here. I got to change your attendance. Yeah, when did you get here? I'm just going to say you were just off by like 10 minutes. And who else? Aaron, are you here? Aaron, no, Aaron is still not here. Okay, let me just save this, and the attendance is done. And great. Okay, let's clear this. Let's try some of this stuff. Okay, here. Practice. Determine two angles, one positive and one negative, that are coterminal with 50. Remember, that means coterminal with 50 means they all will have a multiple of 360 added to it. So, Aiden, just give me a random integer. Random positive integer. Oh, you suck. 50 plus 360, 88. This means I am rotating 88 times, so 88 times 360, and then adding another 50 to it. That's basically what Aiden is saying he wants to do. Oh, I can't believe you did that to me. 360 times 88. That means that's 50 plus 31,680. So 31,730 degrees is coterminal with 50. I rotate 88 times, but my terminal arm still lands at 50 degrees. All right, someone else who would like to be nicer to me, can you give me a negative integer?
-3.
There. Thank you. Abby, you're the best. So that means I am rotating in the clockwise, into the negative direction. So let me just show you. Aiden rotated in this direction 88 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you get the point. If I am doing in the negative, I am going in that direction, and Abby is 1, 2, 3 times before stopping at a positive 50. So this is 50 minus 1080, that is negative 1030 degrees. What does that mean? Negative 360, and then negative 720, and then an extra negative 310 degrees, which is the same as going positive 50 degrees. You can also go backwards, like this. Determine whether these two are coterminal or not. In other words, 570 plus 360 times n, does it give me negative 630? 63, sorry. What would you estimate the integer to be? Someone other than Aiden or Abby?
2.
Yeah, or negative 2. Let's try negative 2. So 57 degrees plus negative 720 gives me, bust out the calculator, 57 minus 720, negative 663. That means theta and sigma are coterminal. What about the next one? I'll give you a few seconds. Are they coterminal? Anyone? What do you think? No? Shall we try one more time? Because this is 1045, I think the closest I can get to 1045 is if the integer is a 3. So that's 45 plus 360 times 3, that's 1080. It's already a little too big, isn't it? That's 1125 degrees. And if I were to make the n value a 2, I don't think I'm going to reach 1045. I don't think I'll be able to do it by adding 45 degrees to it. And so, well, I could try it. How about I just try it? 45 degrees, one number under 3 is 2, so 720. If I add it, it becomes 765. 1045 degrees is in between those two numbers. They are not coterminal. Okay? Any questions? All right. Is everyone all right so far? Do you need a quick break? Or how are you feeling?
Good.
Everyone's okay? Coterminal is decent, it's doable. You can wrap your head around it, you just need some practice. I'm guessing that's your feel. Some of you might be like, just get over it so I can go back to studying for the test. It's understandable. Understanding, I think. Oh yeah, that's what I like to hear. You don't have to understand it 100%. I'm not asking that of anybody. But just see if you're able to just entertain the thoughts and be like, I wonder what that means. That is already leaps and bounds beyond what you were before. Okay? I'm going to clear this. I'm going to start introducing some of these questions that not only put this, but we're putting cast rule together. And I'm finally going to get to show you why cast rule is so useful. And remember, you don't have to understand all of this at once. We are going to look at some more of these questions tomorrow after the test. Okay, so let's keep it simple. Maybe we can try doing the first 3 questions, but we'll go as far as we can. Slowly, of course. We'll go as far as we can. Okay, so the following questions we're going to do, here are some helpful tips. You do want to check which part of the cast rule is going to be used. In other words, you want to check what quadrant you're dealing with. You're gonna ask, it's gonna be, you are going to check what this thing called the related acute angle or the reference angle is going to be, and I'll show you what that is. But these two are probably the most important points. You're gonna see me doing it every single time. So take a look at this example. All right. Question 1a, let's start off slow. Determine the 3 exact values of the primary trig ratios for angle theta in standard position determined by point 4, -3. So just so you know, 4, -3 is right here. That is 4, -3. Which quadrant is it?
4.
In the 4th quadrant. Keep that in mind, okay? I'm going to put a big Q4 here. All right. We have my x, we have my y, All we need is a hypotenuse, aka all we need is our radius. So 4 squared plus negative 3. Oh, I'll stop right there. The reason why I'm doing Pythagorean theorem, in case you missed it, is because I can pretend that a point of 4, negative 3 creates a right angle triangle with base 4 and a height of negative 3. So if I want to calculate the hypotenuse, or the longest side, the C side, I'm going to take those two sides and make that equal to the radius squared. That is 16, 9. So r squared is 25, which means r is going to be 5. Remember, I'm not dealing with a negative. I know square root, you get a plus or a minus, but we don't need the minus. Radius is just a positive. So now that we have x, now that we have y, and we were able to figure out radius, sine of this angle, whatever that might be, is going to be y over r. Cosine is going to be x over r. And tangent is going to be y over x. What do you think? So far, so good? Okay. Okay. Are you ready? I hope so. The question here says, this is cast rule, all right? Determine the measure of the angle of this. And so some of you are thinking, oh, can't I just measure this? No, here, take a look. Please remember that every time we deal with an angle, it's always starting from the x-axis. When I ask for the angle of 4, negative 3, I want this angle. I want that one. So what is that angle equal to? Oops, careful, sorry. What's that angle equal to? And you might be stuck. But remember, I'm gonna erase this for a second. Okay? Let me just do this again. I want to know what that angle is, but remember, using cast rule, this triangle that I have is basically the same as if I had drawn this triangle right here. Or rather, very, very similar. The only difference is the y value is a negative. So instead of dealing with a negative value, let's pretend the triangle I'm using is 3 and a base of 4. So far, so good? What do you think? I'm going to move on, and then you can ask me a little bit later. I'm going to pretend we're going to use that triangle. So sine of theta is going to be opposite, which is 3, hypotenuse, which is obviously 5. So this is in quadrant 1, okay? Using your calculator, let's figure out what the actual angle is. Inverse sine of 3 over 5. Could someone work that in their calculator, please? I will wait. And the faster someone does it, the faster you're done for today.
37 degrees.
30, yeah, 37. Let's round it then. It's like 36 point something, 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 I think. So 37 degrees. So let me use a different color. I will use dark green. So this angle right here is 37 degrees, which means what is this angle? What is the angle that we originally have in the bottom? Anyone?
37.
It's the same. Thank you. It's the same triangle. That's what I'm getting at. Okay? So that's why this 37, we call this the reference angle or the related angle. Oh, you can't see that, right? We call this the related angle because that angle can be found anywhere we draw this triangle. Sure. Um, in terms of getting this, what you're gonna have to do is what you want to do is you want the theta all alone. So how do you reverse the ratio of sine? You're gonna have to use a calculator. In your calculator, you press shift or second button, sine, which your calculator will register as a -1. And inside you put 3 over 5, and you should get 36.9 something degrees, which we rounded to 37. Right. Okay, so that's called the related angle because you're going to see it. And this is going to pop up again and again. So even if you don't quite understand where this related angle comes from, just know that we identified 37 to be this on this imaginary triangle in quadrant 1. And that same angle can be applied to our original triangle in quadrant 4. Okay? So, if this angle, let me erase this. Now that we have established that this angle right there is 37 degrees, what is the actual angle that we want in a clockwise direction? Well, you know that a full circle is 360. So from the 360, just take away that portion and you have your angle. So 360 minus 37, the angle that we have been working with is 323 degrees. You might be asking, why the heck are we doing this if we can just use the calculator? Well, try it. If we want to go straight to this, try it. Try inverse function of, so inverse sine of -3/5. You won't get 323 degrees. What you will get, I believe, is 200 and something degrees. You get something completely different. And we know that's wrong. So there's a reason I'm asking you to go through it. You're going to have to walk with me blind until you get the hang of it, and it'll make more sense, at least for now. I mean, we only have a limited amount of time today, so I'm going to show you how to work it. That's your first exposure to using cast rule. I'm going to try a second question, and you'll start to see a repeat of what's happening. Okay? Clearing this. Question 2. Okay, point P is 12 centimeters from the origin. Oh, that tells me that that's the radius. Okay. An angle is, negative 130 degrees. Determine the coordinates of P correct to 1 decimal place. Okay, I can do that. Let's start by drawing with a different color. An angle of negative 130 degrees means I'm going in this way, right? Remember, If I'm going in that direction, each quadrant is basically 90 degrees. So if I go negative 90 degrees, I have to go only an extra negative 40 degrees. So the point I am dealing with, if I rotate negative 130 degrees, is about here. That is negative 130 degrees. And that means this portion right here would be 40 degrees, which means this portion is going to be 50 degrees. If you're wondering where the 50 came from, again, I know that a quadrant is 90 degrees. If I already took up 40, then the remaining piece has to be 50. And so please take a look once again. This portion right here, that the angle that I am making with the x-axis, that is going to be my related angle, my acute related angle. My theta r, which is my related angle with the x-axis, is going to be 50 degrees. Just to point out. Okay. So let's pretend that I have a triangle. The angle is 50 degrees here, and my hypotenuse is 12 centimeters. What's my y value and what's my x value? The y being sine 50 is equal to opposite over hypotenuse, and cosine of 50 is equal to adjacent over hypotenuse. This means y is equal to 12 times sine 50. If someone can do that in the calculator for me, how about who can I get going? Who's on my list? Alex, if you're with me, can you just punch that into the calculator? 12 sine 50. And for cosine, x is equal to 12 times cosine 50. Anna, if you can do that for me, that would be great. Alex, we got 9.2, excellent. And 7.7, excellent. So we have the y value is 9.2 and the x value is 7.7 on a triangle. But what if I were to apply that same triangle in the third quadrant? It's not just a 9.2. I'm going in the downward direction. It's actually, we have to remember, it's a Cartesian coordinate. And so the y value is negative 9.2. And the x value also, it's in the third quadrant, which means it's actually negative 7.7. The coordinate point of P, that gives me a radius of 12 and an angle of 50. P is negative 7.7 and negative 9.2. The take home from this question is, notice that I'm still using 50. I'm using 50 as if I have a triangle of 50 here, right? And I'm calculating my y, I'm calculating my x. But remembering that it's in quadrant 3, the y and the x have to be changed accordingly. So again, sine of 50, cosine of 50 is, it's going to be 9.2 and 7.7, but because it's in quadrant 3, the y value is going to be negative, the x value is going to be negative. We'll try one more, and then from there, some people might have a better hang of it. I'm gonna open up the floor so you can ask questions about any of these three questions. Okay. Number 3, a point lies in -5, -3, so right there, -5, -3. It lies on the terminal arm, that's in standard position. Determine the exact value of sine theta. Oh, I chose 12 because the question said, is 12 centimeters from the origin? So I know that the radius is going to be 12. So the hypotenuse is going to be 12. The question asks for sine theta, which is y over r. And so that's already easy. We already have the value of y, but we don't have r. Right? So let's take a look. How do you find r? Well, it's the same idea. This arm, this triangle, with a x value of -5 and a y value of -3, I can simply pretend that this is a triangle in the first quadrant with a y value of 3 and an x value of 5. So what would the radius be? 3 squared plus 5 squared is the radius squared. That's 9 plus 25 equals radius squared. This equals 34, which means radius is square root of 34. Place that in there, sine theta would be, technically, sine theta would be 3 over root 3 over 34, but it's in quadrant 3. And quadrant 3 tells me that my y value has to be a negative. And so sine theta in quadrant 3 is going to be negative root 34.
I have a question.
Yes.
So I know last unit we learned how to rationalize denominators.
Mm-hmm.
How do we know like when you're supposed to or not?
Oh, right now you're supposed to. I just left it
Oh,
there just to see. So I
okay.
don't, at any point, we don't want radicals in the denominator. So if I were to rationalize this, it would be negative 3 root 34 over 34. Again, just to throw back just a little bit, the reason I keep on mentioning things like quadrant 1, quadrant 3, remember CAST rule, C-A-S-T. In quadrant 3, the only ratio that's supposed to be positive is tangent. What am I dealing with here? It's a sine. And so we have to change it from a positive to a negative.
I have a question.
Yes,
Um, do you have to switch it to positive? Like, if you kept it, wouldn't you get the same answer?
you would. You absolutely would. I sort of forced that idea because sometimes um, you're not given the point. All you're told is that you're in quadrant 3. Or, that's a bad example. There are times where you're given this, right? And then you're told it's the same idea but in quadrant 3. So you need to be able to identify the negative either way. So I sort of forced that idea. But you're right. You're right. Um, is there one where I can show you this? Oh, there is. Okay. Any questions about where or how we did these past three questions. Because if not, I think there's another one that might bring it home of why cast rule is so useful. No? Okay, you want to see it? Here we go. Clearing. Please jump straight to the next page, number 2. Determine the exact value of cosine negative 225 without a calculator, like it was a quiz. All right, ready? 90, 180, an extra 45 degrees. We're dealing with that right there, okay? So in other words, cosine of negative 225 is that line. What's the answer? Like, they don't give you anything. They just say, what's the answer of that? Well, take a look. I hope everyone's ready. If this is 90, 90, and this is 45 degrees, okay? You can say that I'm going to pretend that I have a triangle with angle 45 degrees in quadrant 1, right? So in other words, my related angle or my reference angle is going to be 45 degrees. What is the cosine of 45 degrees? Can you use your knowledge from 4.1, special triangles? Anyone remember?
Root 2 over 2.
Yeah, 1, 2, 3, 1, 2, 3. Divide by 2, divided by 2, divided by 2, divided by 2, square root, square root. So cos 45 is square root 2 over 2. So the answer to cosine of negative 225 is actually the same as cosine of 45 because I'm drawing the same triangle, aren't I? Except CAST. The only ratio in quadrant 2 that's positive is a sine. Therefore, cosine of negative 225 degrees is actually a negative 2 over 2. So another question. Should we... We can try number 3b as well. How about we do this as a last one, and then we'll take a look at it again after the test. Okay. What are the possible angles of sine theta equaling negative 1 over root 2 in a domain of 0 to 360 degrees? Okay, first off, I don't know what the angle is, and this is a tough one to do. It's got to be a negative, so take a look. If the sine value is a negative, using cast rule, it gives us an idea of which quadrant it's going to be. C, A, S, T. In the first quadrant, sine is positive, so it can't be here. In the second quadrant, sine is positive, so it can't be here. In the third quadrant, sine is negative, so the angle that we're dealing with must be here. And in the fourth quadrant, sine is a negative, so the angle that's possible here, it must be in quadrant 3 and quadrant 4. So therefore, it must be quadrant 3, and it must be in quadrant 4. Now, let's pretend that it is a positive. So if sine theta was in fact positive, what are the angles? In other words, what would the smallest angle possible be? Anyone remember? Going once, going twice. Theta has to be 45 degrees. If 45 degrees, if a triangle with an angle 45 degrees gives me this answer, right? The same triangle in quadrant 3 and the same triangle in quadrant 4 should give us the same answer with a negative. So in quadrant 3, a triangle of 45 degrees would mean we first turn 180 and then add the extra 45. That's 225 degrees. In quadrant 4, if this is the angle we're dealing with, that's basically a full 360 subtracted by that triangle's angle. So that would be 360 minus 45 degrees. That is 315 degrees. We're slowly exposing ourselves to the idea that sine and cosine and tangent could have negative values, and the implications of that means it must be in a certain quadrant that makes the values negative. The x value or the y value or both must be negative. And that is the essence of cast rule, being able to see what's negative and identifying which quadrant it is. All of the questions you will see in this sheet are basically taking that idea and stretching it to see how far we can take cast rule and how much can it help us in answering questions.
So the -1/√2, like the negative part, is only important for determining what quadrant it's in?
Exactly.
Okay.
The value itself, we know that that has to be some form of 45 degrees, right? We know that it's got to be either 45 degrees here, 45 degrees here, 45 degrees here, or 45 degrees there. It's one of these four triangles. Because you know that cosine of, or sorry, because you know sine of 45 gives you 1/√2. Because it's a negative, cast rule tells us that this one is a no-go because it's supposed to be a positive, and this one is a no-go because it's supposed to be a positive. Cast rule tells us that the triangles that I'm dealing with must be in quadrant 3 and 4, and we start figuring out the angles accordingly. Okay. We'll talk more about this. We'll expose ourselves. We'll try some questions together. Maybe my explanation is lacking. Um, I will try to summarize it as best I can next time we meet, which is tomorrow after the test. At which point, I hope there's been an exposure for you to know what kind of questions you want to ask and what you wanted clarifying to clear up the picture. Okay, let's stop here. Yes, there is homework, but I'm not going to ask you to do that on top of or over studying. Studying will obviously come first. Do that first. Um, don't ignore the quiz study thing. There is going to be an online quiz, but like we're not doing it in person. I forgot to take that off from previous years. Um, and if you look at the next post that I have, there's a whole bunch of more challenging questions, and we can try that next time. Okay? Any questions before we dismiss?
I have a quick question.
Yeah.
Can you just quickly go over that 1/? 2 or root 2. That
Yes.
changed to root 2 over 2 just because you multiplied the top and bottom by root 2.
Yes. It was just quickly rationalizing the denominator. So you multiply by a 1. So the numerators multiply and the denominators multiply.
Got it. Thank you.
Yep. If there's nothing else, you're officially dismissed. Take a break and maybe use whatever juice you have left to finish your brushing up and studying. Do what you can with the study sheet, but don't make the mistake of spending so much time on the study sheet that you actually forget to practice. Have had a couple of students do that. I'm going to stop the recording here. If you want to stick around to ask more questions, you are welcome to do so. Otherwise, we will see you tomorrow at 8:50.